Hello, my name is Jesse Crafts Finch. I'm a programmer and game developer located out of Western Massachusetts, where I run a game development company called Guerrilla Tactics. I do contract work for large companies to help them finish features and meet deadlines, and I do custom projects for individual clients. I've been using Bolt for several years now on 3 commercial projects and several personal projects, and this presentation is going to be basically me sharing my recommended practices for using Bolt. I want to be clear that these are not necessarily the best practices. I think it's arrogant to say that something's a best practice, and I always think there are multiple ways to achieve the same goal based on your project needs. These are simply the ways that I have found and recommend that you use Bolt to get the best experience with it. In this presentation, I'm going to assume some knowledge of Bolt, but in case you don't have any, I'm going to give a quick overview of what it is and how it works, and then dive into the details. I'm going to go through this pretty quickly, so if you could hold any questions or comments you have until the end, we'll have more than enough time to talk about it afterwards. At its simplest, Bolt is a visual graph editor. That means it's similar to the VFX graph and shader graph. It's going to try and turn the experience of coding in text to one of dragging and dropping nodes on a graph. And for controlling application flow and input control, it works really well. When people try and bill it as an entire replacement for programming in a game, I'm going to have to give that a big nope. Before we really jump into the recommended practices though, let's give a brief overview of how Bolt works in Unity. The Bolt system is made up of 2 major components, state graphs and flow graphs. State graphs are containers. They hold references to other state graphs and flow graphs, and then also establish the transitions between them. Flow graphs are where your game logic happens. It's where you call methods on your scripts and you actually control what's happening in the game. A flow graph will be where you're listening for input and determine based on that input where you're going to go and what you're going to do. My first recommendation is that you keep your logic in your code. I'm going to tell you why while I play 2 quick examples of writing the same logic in Bolt and writing it in code. The primary reasons you don't want to write logic in Bolt graphs is that it's messy, it takes more time, and it's hard to duplicate. As you can see here, we're just writing a standard add and clamp function, but there's already a lot of nodes. It makes it hard to read, and if you want to duplicate that later, you need to copy and paste this structure to where you want it to reside. If you want to go back and change how that function works, you have to change the graph in every location you have that copy and pasted to. That's not good. When we compare that to writing our logic in code, it's much better. We can write our logic easily. It all resides in one place. Your programmers are used to seeing that logic in code, and you can do more complicated things with it. Also, even if you're referencing that code from multiple locations, if you need to change it, you're just changing it in the one location that you're referencing it from. This is much cleaner, and it's why we're going to keep our logic in code and not in a graph. Just a note on the word logic. I've just recommended that you keep your game logic in code and keep it out of Bolt. I'm now in the rest of the presentation going to sometimes use the word logic to refer to what we're doing in Bolt. Just to be clear, I'm referring to application flow and input control logic, not game logic. Game logic stays in code, application control and flow logic is fine in Bolt. I know it's confusing, same term, different definitions, but that's where we are in life. My next recommendation concerns where we're going to store the data for our state graphs, and there are 2 options in Bolt. One is you can have them embedded, which means they're serialized with whatever game object they're attached to. And the second is to use what they call macro states, which simply put means you're saving the data in a separate file. I recommend that you use macro states and avoid embedded like the plague that they are. The first problem is that embedded graphs are saved with the game object that they're on. They're not in a separate file. So if you delete that game object, you lose the graph. Here's a real-world example. Yeah, that's a pretty sweet graph I got. Yeah, put a lot of work into that. Many hours. Well, I actually need to put this on some other object, so I'm going to delete that and add a new game object, and I saved it. Oh, wait. The second problem you run into is less dramatic, but still important. Let's say you have a pop-up, and it's got a nice embedded state graph, shows the pop-up, waits for the input, and then closes the pop-up. This is something you might want to have used in multiple locations. You might want to reuse that graph. But because it's embedded, there's no easy way to copy that functionality to another graph or another object. There are two locations where you have to ensure that your graph is listed as a macro and not an embed. The first is when you create a game object and you attach a state machine to it. It's going to create this default inspector, and it's going to default to macro. That's great. Keep it that way. You'll be able to select either an existing macro that you have, or you'll be able to create a new one and save it in the file that you want. Right now, we're just going to select AppFlow, and now we can open it. All right. The second place we have to worry about embeds is when we're in a graph and we create a superstate. A superstate is just a state inside another state. That's all it is. And as you can see in the upper left, when we select it and get some details on it, it automatically defaults to embed. We want to make sure that we switch it over to macro. Okay? If we don't, here's what happens. We have my state, and inside of it, let's just have a start and a transition. Okay? If we copy this, it will be identical inside. But if we change one of them, that change is not propagated to the other. That can be confusing, problematic, etc. So instead, what we're going to do is we're going to make sure, like the game screen, we're using a macro. If we copy this game screen over here, because we want to access it from some other location or whatever your use case is, we can look inside and see that this is what we have, playing the game after start. If we create a new transition here, and we go back out and over to this game screen, the change propagates to all game screens that use that macro. And that's the second benefit. One, you can't accidentally delete it, and two, you can reuse the functionality and the states in multiple locations. My third recommendation is that you use static strings for bolt events rather than manually inputting strings into the graph. Here's an example. Let's say we want to create a transition between main menu and game screen. We have to trigger this transition somehow, and a standard way of doing that is by listening to a bolt event. We're going to go in here, add a node for custom event, and have that cause the transition trigger. In here, we're going to say, well, because it's between main menu and the game screen, it's new game. Okay? Anytime an event is fired with new game, we're going to trigger the transition. However, because you're manually entering the string, you run into the problems with strings that you have everywhere. Let's say that there is some other state that you want to transition to the game screen from. We create a transition. We create a custom event. And now we have to remember what that other event is. I don't remember, so I'm going to go back. New game. Okay. I'm going to go back over here. New game. And there's the other problem. Misspelling. Happens to everybody. and then you spend an hour debugging something to only find out that you put in the name wrong. So that's a little taste of why using strings is a bad idea. If we go into code in the scene controller, let's say we want to trigger an event. Custom event, trigger. We give it this game object and the string name, new game. Again, we're relying on strings and the human error that goes along with them. Let's avoid this whole problem and just use static strings. To get static strings for bolt events working, there's a couple steps. Let's go through it one by one. First, we're going to create a script. We're going to call it bolt events. When we open it in editor, we can actually not have it be mono behavior. That's fine. But we do need to make it static. Now let's add our event, new game. And all that's going to do is get the name of the new game field. So now we have that. Great. Now we're going to go into our graph, into our transition, and we want to replace this manual input string with ours. So we're going to search for bolt events, and nothing pops up. That's because bolt mostly only auto-detects mono behaviors. So if we wanted to detect bolt events, we need to specifically tell it to see it. We're going to go to Tools, Bolt, Unit Options Wizard, and we want to go over to Types. Once we're down there, we're going to add our type, bolt events. Boom. Generate. Now that that's regenerated, we can go back into the map, into our transition, and it should pop up. Boom. New game. Boom. Now we're accessing a static string, and we're not manually inputting it. We can copy this and put it elsewhere. So if we have another superstate with another transition, we can put it in here. And also, if we're in our code in the scene controller, instead of new game, we can just reference bolt events.newGame. And that is much cleaner and safer than manually inputting strings into your bolt events. My fourth recommended practice is to not use bolt's variable system. My standard response when anybody suggests using that variable system is,
No, God! No, God, please, no! 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 No!
I obviously have strong feelings about this. Here's how Bolt wants you to use variables in the variable system for Bolt. You have an object, store1. On that object, you have a graph, your store graph. Inside that graph, we have our state graph and a flow graph called loadStore. In loadStore, we're calling storeController.loadStore, which takes a float for our data. We can manually add it here on the graph, but normally you're going to want to input that in code somewhere. So you're going to want access to a variable that you're setting outside of the graph. Here's the way that Bolt wants you to do that. You go to the object, store1. You go to variables, and you add store data. We're going to say it's a float, and we're going to add 3 as our data. Now, once we go into the graph, into the load store, we can say, we can see on the left here that we have access to store data. We drag that over here. We put that in there. Bada bing, bada boom, we got access. That seems nice. Now, it's been a while since I've used this variable system. I've been using a different one for quite a while now, so I might not remember all the problems with it, but let's just go through the ones I can think of off the top of my head. These variables don't persist across objects unless you're copying the object. So if you have 2 store objects because you have 2 stores, you may be using the same controller, but you want the visuals to be slightly different. If you click on store 2, you can see that the variable is not there anymore. Store data exists on store 1, but not on store 2. So you have to remember what that variable is, or go into the graph to look, and then add that variable here as well. You can't refactor the variables. So if for whatever reason we want to change the name of store data to store info, we can do that here in the variable section, but once we go into the graph, we can see that it's still referencing something called store data, and we need to change that to store info. On large graphs, this becomes impossible. Now instead of using the nonsense machine that is Bolt's variables, we're going to use our own. For every object, or for every graph that we have, we're going to create a variable script. We're going to keep the name short for usability. So we have our store, and we have store vars. Now we're going to go to our object, which references store, and we're going to add store vars. This is a simple example, but it's important to note that if you have any graph which references a store graph, you're going to need to have a store vars script on that object. This is a simple mono behavior, and we can edit it like that. All right. Now if we go into our graph, into load store, we still have our method call. And instead of dragging the variable from the left here, we're instead going to access store vars dot data. We're going to get it. It's important that whenever you try and access a field on a script, it's going to check and do get component on whatever object the graph is on. So in this case, that's why we have to attach store vars to the object that our store graph is on. Now we have access. If we go to our other store, we also need to add store vars. But unlike the previous situation where we would have to manually add all the variables that the graph needs access to, just by adding the script, we already know all the variables that needs access to, and we provide access to those variables. My last recommended practice is to use Bolt events to trigger transitions between states and not tie those transitions to specific controls. That's a little confusing in the abstract. Here's what I mean. Let's say we have our main menu and our store, and we're able to get from our main menu to our store, and we also want to be able to get back. So we create a transition to go back. In that transition, we're going to access our store vars, which we set up earlier, and an X button, which I added afterwards. We're going to trigger on the X button clicked. Great! Now whenever the X button is clicked, we're going to transition back from the store to the main menu. There are two problems with this. One is it is brittle. It is tied specifically to the X button. If the X button changes or you want to add more transitions, you will need to add more here, and this gets messy. Let's not do that. The second is whenever this transition occurs, based on the button click, it immediately transitions between these states. It does not provide any cleanup. It does not care where in the store graph it is exiting. It just does. So in our store, let's say that we're in wait player input and we click that button. It's not going to go over to clean up store before exiting. It's just going to exit, and we're going to encounter problems. So here's what we do instead of that. Instead of a button click, we're going to listen for a Bolt event. And that Bolt event is going to be exit store. This already has one benefit. We can call exit store from code, we can call it from a graph, we can call it from wherever. Use a tuba outside, I don't care. Anywhere that you call it, it will transition to the next state. So we can have multiple triggers for that, which will cause the movement between the states without having to set up an obnoxious number of state transitions. The second benefit is that we can control when that event is triggered. In our case here, we have our wait for player input, and then we have our cleanup store. We want to make sure that cleanup store gets triggered and run before we actually exit the store. This cleanup could be canceling purchases, it could be closing windows, whatever it is, mopping the floors. So in this transition, this is where we listen for the button click. Now, when the user clicks the X button, or any other input that we want to listen to, it will transition from wait for player input to cleanup store. In the cleanup store, we're going to clean up the store. We're just going to do a little simple log message here. Cleaning up, not partying. And then we're going to trigger a custom event. And that custom event is, clearly, going to be exit store. Great. Now, inside the store graph, it controls when it's going to exit. We listen for the button click. It transitions to cleanup. And that cleanup fires exit store, which triggers this transition. This allows for a lot more control and flexibility. So those are my 5 recommended practices for Bolt. Number 1, keep your game logic in code. Number 2, use macro states, not embedded states. Number 3, use static strings on a static class for Bolt events. Don't just type them in. 4, don't use Bolt's variable system. Number 4a, don't use Bolt's variable system. Number 5, use Bolt events to transition between state machines. Don't tie it to specific functionality. That's all I got for you today. I think if you follow those 5 recommendations, you will be better off than if you didn't. We now have some time for me to answer questions. If you have a question, please step up to the podium, and I'll do my best to get through all of them, or embarrassingly, there will be no questions, and we'll just sit here in silence.